Depending upon how it goes, this recording should be all right. Just down here. Okay. Let's look at, I suppose we got to look at the syllabus. We're not going to spend too much time on the syllabus. Oh, these Zoom meetings. I will record pretty much every day. If the recording works, I'm pretty good at it. If you miss class, there should be a recording here. That's not an excuse to miss class. If things happen, miss class. It's up to you. This is not for you to come into this room during a Zoom. It automatically is going to come up every class. I'm going to start the meeting in Zoom. You are not coming in. It makes for a mess. So you are locked out of this meeting. You cannot come in. You can wait for me to throw it into YouTube and I send you a link. So with that, if you miss class, here's some previous semesters. It's all out here in YouTube. If you ever go out there and watch one of my channels or watch my classes in YouTube, you have to subscribe and like, because my goal before I die is to make 1 penny off of YouTube. 1 single penny. And I think I need 1,000 subscribers and 1,000 hours or something like that. I don't think I'm ever going to make a penny off of YouTube, but just bear with me. Just subscribe and let it play in the background forever so I just want them to send me an email. Hey, you're going to get 1 penny. That's my goal. Okay, we'll look at a syllabus here. It should be right here, and then we're going to roll on. When you click on links from me and my course, they're Google Docs. Make sure you download, or they're going to be goofy. So I'm going to download to Word. We're going to download to Word, and then I'm going to open this pig up here. All right. So I think we're all in the right place. Tuesday, Thursday, class 4 to 5:15. We're in Phillips. Office hours, I'll stick around after class, but I'm going to change this to before class because there's nobody in here. Otherwise, Friday, 11 to 1. What do we got here? Everybody knows about a textbook, Chemistry and Chemical Reactivity, 10th edition. How about the OWL? Were you able to buy that at the bookstore? Okay. So the OWL online homework, when I was a little skeptical at first, but students like it. Students like it. So some of you somebody poked around an OWL at all yet? Yeah, some people have. Okay. All right, calculator. We can look at calculator. If you have a TI-30 X2S and you own a gun, you should shoot it. I'll tell you that much. If you need a simple calculator, now don't use your phones because you can't use your phones for the test. Get a dang calculator. No excuses. Oh, I didn't get one. Just get a calculator. If you need a cheap calculator because you stole your brothers and sisters or roommates, get a TI-30 XA. It has to be an XA would be easy. If you go on Amazon, it's $10.34. The reason this is a decent calculator is it has exponent right here. And we're going to do this today. So if I go 2,500, and if I want that in scientific notation, there's an SCI right here. I can hit second 5 and it throws it in scientific notation. If I want to float the decimal, I can float it back. It's got a little fraction key there. It's $10.34. It's an easy calculator. I like it. It's simple. I want simple. Now, if you think you got to be cooler than that and spend about the same amount of money, you get on eBay and you buy a TI-85 for about $16. that is a calculator there is about 30 years old. It'll do the 999th power. Ask the goofball next to you to do that on their calculator, won't be able to do it. 99th power is all it'll go on those new TI-84 plus silver edition or whatever we're on. If you want a graphing calculator that does a lot, has to just buy one for $16, $17, TI-85. They're pretty much bulletproof. Gives you a little bit more. So that's my advice on calculators. Take it or leave it. All right, we've talked about calculators. We're back to the syllabus here. Calculators. Make this bigger. You can read this over. I am not going to read this to you. But almost every day, when you get done with this class, you should try to do the homework as soon as possible. Try to do it right away every day. Or at least tomorrow morning. Don't wait. We have take-home quizzes will be 17.5% of your grade. You'll see that today. We'll start. I'll give you some take-home quiz questions. So now that I have the take-home quiz, we're talking about it. Here's how the class kind of goes. This right here is basically what I call a learning guide. It's a mini textbook that I've created. Hours and hours and hours. Okay. There's example problems in this that we're going to do. There's tables, there's diagrams. It's a mini textbook because students don't look at their textbook. I do know that much, right? I have went through the textbook. I've been online and I pulled what we need to really grasp onto. I call it a learning guide. It's a mini textbook. I will send you this as a Google Doc. You download it to Word and then use a notes program or bring it paper pencil. We're going to go through some of this today. We're going to get so far and I'm going to pull out the quiz and I'm going to say, hey, here's the quiz. So far, you should be able to do 1 through 4, 8, and 9, maybe today. And I'll write it up here. When we have class on Thursday, if you have any questions on this that I assign today before class, you come up here, write the number up here. And we'll do the question we'll do the question after class starts. We get towards the end of this learning guide, I'm going to say, hey, you should have this all done. You're going to put the answers in Canvas. Now, let me rephrase that again, or say it again. You're going to put your answers in Canvas. This is not a pop quiz. This is a take-home quiz. We're going to work on it as we go. Eventually, it's going to be done. There's going to be a deadline in Canvas. You're going to open it up. It's going to be the same exact question. You're going to put your answers in. Then I'm going to go to the next learning guide. You're going to have another take-home quiz, and we're going to keep going. And we have the OWL homework as we go as well. So every day, we will go through example problems. We're going to talk about diagrams and stuff. Mini textbook, if you will, plus all the example problems here. We're going to have quiz questions that go along with it and OWL homework. I'll say, hey, you should be able to do OWL homework to here. And I will have OWL homework example problems in here as well. So this one, not so much. But as we go forward, I'll have exact, if I'll explain something goofy or I don't like it, I'll say, here's an ugly OWL question. This is what it looks like. And we'll do it right here before you see it. Get frustrated. Okay. Let me rephrase and review. The format of the class will go like this. We're going to go through a learning guide. You're gonna have quiz questions that go along with what we are presenting for today. You can do those quiz questions on your own. You can ask people for help. I don't care. It's a take-home quiz question. If you need some help from me to do it, put the number on there before class starts. Because when it comes to the test, what are the test questions going to look like? Take-home quiz questions. That makes sense, doesn't it? You should kind of have some take-home quiz questions that look like the test questions. We're not going to have a test until we get down to chapter 3. It's going to be so that's the format of the class. Let's go back and see what I missed in the syllabus. So we've got take-home quiz questions, so we know what those are, correct? We have take-home quizzes. As we go, you're just going to enter your answers in Canvas. The exact same question. It's going to be the exact same question. It's going to be scrambled. The order might be scrambled, though. So I want to keep it in the same order. So you go to enter your answers. You know, question 6 might pop up as 20. The OWL is 17.5% of your final grade. So after today, right, I'm going to say you can poke around an OWL right now. Poke around an OWL. When you get the OWL done, you still have to submit OWL, and it goes right into the Canvas gradebook. So let me say that again. When you're done with OWL, you still have to submit. It'll go into the grade. Now you should get 100% on your OWL homework. You've got all kinds of time to do it. I think you get 6 or 8 tries to get it right. I mean, and then it'll, if you get the first time wrong, it'll kind of explain to it. It really does a pretty nice job. So you should get 100% credit on the OWL homework. OWL will assign a 10% late penalty. 1 second, 1 day late is late. That is done by OWL. Okay, so we'll look at where the deadline is, but if you submit the OWL late by 1 second, it whacks you 10%. Otherwise, the quiz is 1.5% per day for 14 days. And 1.5% is not going to destroy anybody's grade. And what it really does, it prevents me from going into Canvas for every one student. Oh, I had the flu for a couple of days. Okay, well, 1.5% per day is not going to destroy your grade. It's not going to do it. So I don't have to go in and change stuff. But it gives you 2 weeks grace period, kind of. Then there's 3 units exams and a final exam. The unit exams, I've got them in the schedule here. I've got March 5 or 7. It's going to be this week. Unit 2 exam, I've got April 9 or 11 in the last exam. So it's going to be that week. I've kind of flexed it of what day it's going to be. Obviously, when we get close, we'll nail it down, right? That's the grading scale. I think that's about it. Oh, other than one thing. I've got it here somewhere. Where is it? Right there in yellow. Final exam is when it is. Unless you can show me a plane ticket Thursday. I don't know when the final, does anybody know when the final exam is? Yeah, they take like a week to get it out. I don't know why they get their crap together. It doesn't make any sense. It doesn't change, it's been the same, but they don't put it out after a week or 2. It makes no sense. The final exam is when it is. Might be the first one, might be the last one. I don't know. But it just is what it is. Do not ask to take the final exam online. We don't do any online exams. I'm glad you're all sitting down. It drives me freaking insane when you have a lazy ass face-to-face teacher. I didn't have to put this recording this. You got a face-to-face teacher that gives everything online. That's a bunch of BS. Glad you're all sitting down, because if you do online tests, guess what? Glad you're all sitting down. Students cheat. Ooh. So we have face-to-face paper pencil tests. Okay, face-to-face paper pencil tests. Please, whatever the final exam is, it is what it is. The only exception will be if the college changes the date of the final exam. And this happened in the so-called bomb cyclone that really wasn't a bomb cyclone, but they shut the college down midway through the final exams, I think on Wednesday or something. So it is all set. I don't know when the final exam is. All right, any questions at this point? Questions? Okay, I'll tell you about myself a little bit. I sat in chemistry class in this place right about there. Or maybe I was right there. I graduated from here in chemistry last year. No, I wish. No, that's last year. So, I'm from Arkansas, Wisconsin. Follow the Chippewa River, you come to Durham, Wisconsin. At 3 miles from Durham, you come to Arkansas, Wisconsin. That's right. I grew up, graduated from high school. I'm a farm kid straight off the farm. So I say farm phrases. Went south for a couple of years, went to Bear Falls, didn't like that, dropped out of college. Didn't wait very long, came here to college then for chemistry and math. Then I taught high school chemistry, physics, and math right there for 11 years. I teach at Chippewa Technical College as well as here. So I'm still a farm kid. Got my 5 cows. Gonna have 2 calves, May and Darla. Gonna have 2 of my teachers. And then I'll probably bring pictures of like every 8 months. So I'm still straight off the farm. I cannot get away from the farm. So I live in Mondovi, Wisconsin now. There's a barn on a lake in Mondovi there. Ever been there? That's me. We actually have a wedding barn. It's a wedding barn. My wife and I got some cows, but straight off the farm. Okay, we're going to get started with class here a little bit, and we're going to go through our learning guide, but I'm going to introduce our SI. I got it right, Bailey? You want the microphone? All right, stand up, project yourself. Chemistry goddess that she is, right here.
Yeah, maybe.
Yes, for sure.
My name's Bailey. I'm a sophomore. I'm a nursing major, so I'm your guys' supplemental instructor. So what that means is we meet 2 times a week for a half an hour or an hour and a half. I'm like a big study group, so I will organize activities that we can do, study questions, just to prepare you for the exams. I'm another resource besides Mr. Keys, Dr. Keys, to ask questions. I'll have office hours. Yeah, that's about it. Don't be a stranger. Everything's anonymous. Nothing that is said in the SI session goes back to Keys. So yeah, I hope to see you guys all there.
And you'll have a schedule, events.
Yeah, that'll get
all that stuff.
Yeah.
Okay. That was one thing I just thought of. I can't remember. I was gonna say. Questions at this point? It's gonna come to me. Questions? Yeah. Oh, the final exam?
Yeah, final exam.
Final exam is going to be in person.
In person.
Yes, in person.
Everyone.
The final exam, I think is in this, they're usually in the same classroom. I think it's gonna be here. The final exam, I think is in this classroom. What time it is, I have no idea. What day it is, I have no idea. So all of your exams will be in this classroom, paper, pencil. You're gonna actually get a paper, pencil test. including the final. Okay, well, let's do it. We're gonna start here. So I should be sharing, I should be recording. We're on this right here. Now, everybody's background is different. Some of you know how to do this pretty good, fine. Others do not. Everybody is at a different point in here. Please respect that. I will tell you what to write down and what not to write down. And right now I'm going to tell you, do not write this down. Watch. What's the answer to that? What's the answer to that? 9, right? Sometimes I brain fart and put down 6. Happens, right? We know that this is 3 times 3. Okay. We then know that this is 10 times 10, which is 100, correct? Do not write this down. Now you've got this. So we have 2.12 times 10 to the second power, or basically 2.12 times 100. Yes? I need a show of hands. Do not. I want 100% participation. How many of you are going to move that decimal? Well, how many of you are going to move the decimal? That much 100% participation. On the old parts. The decimal does not move anywhere. And you don't move the decimal anymore. You got to get with it. Be the hipsters. The decimal does not move anymore. You tell an elementary student to move the decimal, they're going to look at you like you are on another planet. And I am not lying right now. Can somebody verify this, please? Somebody? Yes, I've got some shaking the head. The decimal does not move anymore. For you old farts, yes, I agree. You're going to move this decimal to the right 2 places. Agreed? And you would get an answer of 212. Yes? Now, I'm dead serious. The decimal stays locked in place. Don't you mess with that decimal. The modern way to do it, you move the numbers the opposite. Lock the decimal in place. Same, yes? So the decimal doesn't move. I'm going to move the decimal to relate to you old farts. So I will move the decimal. Now, do not write any of this down. So we move this decimal to the right because that's equivalent to 100, correct? And you've been taught, well, this has 2 zeros, so I'm going to move the decimal 2 to the right. What does 10 to the minus 2 mean? One over 10 to the positive 2, correct? Does this look correct as a math identity? 1 over 10 to the positive 2, which is really 1 over 100, which explains if I have 2.12 times 10 to the minus 2, that is the same as 2.12 over 100, isn't it? Which is why now we're going to move it to the left, correct? Left 2. So if we have a negative exponent, we're moving it to the left. If we have a positive exponent, we're moving it to the right, correct? All right. So that's a little bit of review. Let's go over to this scientific notation here. When we have a number in scientific notation, if we have a number in scientific notation, there is going to be one number to the left of the decimal. Right? One number to the left of the decimal. If we have a number larger than 10, we're going to have a positive exponent. If we have a number that is less than 1, we should have a negative exponent, right? So if I take this one right here, this is going to be, go ahead and write this down, fill this in with me. Positive or negative exponent? Positive exponent, yes. My decimal is right here, and I'm going to move this right to there, yes? Because then I get one number right there. I got one number to the left of the decimal, and I'm going to get 5.6 times 10 to the 5 places. Is it 5 places? Yes. Okay. Over here. Negative, right? For sure. Negative exponent. This number is less than 1. I'm going to take this decimal and I'm going to move it to the, I need to put it right here, correct? Remember, I always want one number to the left of the decimal. Just move it so there's one number to the left. So I'm going to get 8 times 10 to the negative. Negative 4, huh? Yes. Number 3. What am I going to do there? I'm not going to move it, am I? So if I truly put this in scientific notation, what do I got to put here? I got to put a 0 there, correct? 0. What's 10 to the 0 equal to? That decimal better not move. Yeah, so 10 to the 0. 10 to the 0, 1. 999 to the 0 is 1, right? Anything to the 0 power, we got a 1 out of that. All right, number 4, what do we get? We move it to there, 7.732 times 10 to the 4th. All right. And number 5, we're going to take this decimal and we're going to move it to the, us old farts are going to move that to the right 12 places. And if we move that to the right 12 places, 3, 1, 1, 2, 4. That would be 4 places, right? I need another 8 zeros on this pig. 1, 2, 3, 4, 5, 6, 7, 8. My decimal's right here, and we're going to the left 6 places, huh? So I'm going to have 1, 2, 3, 4, 5, and then a 5. That would be 6 places to the left. Okay. Now, calculator, calculator, calculator. Oh, man. First thing, I should scream this. You are not ever, ever putting times 10 in your calculator. Please do not put in times 10 in your calculator, ever. I have an online physics class. I get an email. All my answers are off by 10. Oh, do not put in times 10 in your calculator. On your calculator, that's going to be handled by EE or EXP if you have a Casio times 10 to the N or times 10 to the X. Yes. If you have a TI-83, it's in a different color. The EE is in blue, so you got to hit shift the blue to get the EE to come up. And 83, does that sound right? If you have a TI-30 X2S, you have to hit the second key to get it to come up. Now, you can put your calculator in scientific notation mode. Okay. To put this in, this should be 5. EE or EXP. You need a negative button and a 6. Now, make sure you're not using the subtraction button. It should be negative. On this calculator, it's here. You're not going to use the subtraction. There's a negative here. Here's the plus minus. Then it should be a times 2 EE or EXP8. And then hit equals. And when you do that, you should get an answer of, go ahead and do that. We get 1,000? Yes. Okay. If we put this in scientific notation, 1 times 10 to the third. Right? Now, let me show you that we did not need a calculator for this. Because I'm setting you up for the last two. 5 times 2 that I have in pink is 10, yes? 10. And when you multiply powers of 10, what do you do with the exponents? Add the exponents, right? So negative 6 plus 8 is 2, right? So you have 10 times 10 to the 2, which is going to be 1,000, right? Now listen. Do not add to my liver damage. Listen. Let's say you've got this. Okay, 2 times 10 to the second power. I like that. No liver damage. You're not going to cause me to go to the refrigerator. This number really is, that's equal to 200, isn't it? 2 times 100, 200. Agree? Yes? So I have a student that wants that the answer is 200. Here comes the liver damage, and they write this. That is not the same, correct? They really mean this, which is 200. What is this equal to? 4, correct? That's 4. Don't be doing that, right? You have to write in the times 10. You have to write in the times 10. There's no shortcut like that. All right, let's do the next one. Let's do it without a calculator. Let's do this first. 4.5 divided by 1.5. 3, yes? And when you divide, you subtract the exponent. So this would be 3 times 10 to the 36 minus 12. Three times 10 to 24. Sound right? Okay. Number 9. No calculator. Nine times 9. 81. Yes. I hope. $400 plus 621. Yes. Add the exponent. So that's going to be 1021. That's not the answer, correct? You still got to fix this. Still got to fix it by moving the decimal. Now, this is not a no-brainer situation. Think about it. Think about it. My decimal is right here. I would move it to the right 1,021 places, yes? But to put it in correct scientific notation, I got to move it to the left once, correct? So I would have 8.1 times 10 to the 1022, correct? If I move it to the left once, I would have to go to the right 1022. I'd have to add 1 to that. Okay. Grab your calculators. Grab your calculators. This drives me nuts. Let me show you what I see students do real quick. Let's say we've got this. 1 point, and I'm just making this up. 1.6 times 27.2 times 18.1. I'm going to divide by 8.92. I'm going to divide by 6.12, and I'm going to divide by 1.2. I see students put in all those parentheses, and just some craziness happens. Here is what I want you to do for this. And grab your calculator. Do not write this down. Multiply the 3 numbers on top from left to right. Go ahead and do that. Multiply those numbers on top. No parentheses, right? You're just going to multiply 3 numbers. Hit enters or equals. So you got the result of those 3 multiplied together. Yes? There are 3 numbers in the denominator. You're going to hit your division key 3 times. Let me say that again. There's 3 numbers in the denominator, so you're going to hit your division key 3 times. Let's divide this from right to left. Divide by 1.2. Divide by 6.12. Divide by 8.92. It equals. There's your answer. Which is what? What's the answer? 1.02? 12.02? 12.02. Okay. Well, let me say this again now. If you got 3 numbers in your numerator, hit your division key 3 times. Don't do parentheses. You got 4 numbers in the denominator, hit your division key 4 times. How many numbers in the denominator? 3. So for this, you're going to multiply these 2, divide, 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 and I'm going to let you do that problem. I'm going to roll on. See if you can figure out number 10. We're going to the next page here. I keep wanting to cut this down, but I can't do it. I just kind of like the write-up. I don't know where I got it. I stole it one time off of it. But that's not, I like to give credit and I feel bad because I want the name up here. I am good at that. I don't know where I got this. I guess I could search and find it, but it's a good write-up. Okay, so we're going to talk about some units of measure. I always say this. The day you come out of the womb, you're chasing units until you're put into the ground. Come out of the womb and your parents bought diaper units and fed you bottle units. And you got older and you decided that you needed money units. Every number has a unit, right? If you consume too many beer units, you're going to consume aspirin units, right? Got an extra boyfriend or girlfriend, you're going to get a headache unit eventually. Guaranteed. Now, every number should have a unit. Except for the geometry number does not have a unit. What's the geometry number that doesn't have a unit? The pi, right? The pi you don't see it before. Okay, so we've got some crazy units like digits, the width of a finger, and cubits, the length from the king's elbow to the tip of the king's middle finger. Yes, cubits. Otherwise, a yard was the circumference of the king's waist. Right? So we have all these units that we're coming up with in the beginning. So we do things here based upon what's called the English system. Yes. If I say inches, pounds, feet, that type of stuff, which comes from England or Britain. Yes. Now, in 1965, they adopted the metric system. They crap canned their own unit, their own system in 1965. We still have the English system. Do you guys know how many people still use the English system in the entire world? Right here. The United States, Liberia, and Myanmar. That is it. You've been out of the country, even to Canada, right? Everything's a metric. Everything is absolutely metric. There's a reason for that. And I'm going to state that reason to you. Here's a pretty good statement. There's 26 letters in the English alphabet. Those 26 letters, it's possible to construct all the words in the English language, right? Makes sense. Similarly, there are 7 letters in the language of measurement, from which all units of measurement are derived. These 7 letters are distance, mass, time, electric charge, temperature, amount, and luminous intensity. These are the fundamental units. So if I turn the page and turn the page again and come back, but there's our 7 fundamental units on this page. Anything you want to describe in the universe, 1 or more of these units put together. This is like the 26 letters of the English alphabet. There's 7 letters here, if you will. There's 7 fundamental units. Meters, kilograms, seconds, coulombs, Kelvin, mole, candela. When you go down below, you've got a combination of those units. So these are the 7 fundamental units. We know in the metric system, have these prefixes, right? That we're gonna use in the metric system. And what's nice in the metric system is this. Everything is uniform. If this is 1 liter, and if I have 1,000 of these, I would have I'd have a kiloliter, correct? If this is a meter, which it is not, if I had 1,000 of these, I would have a kilometer. If this had a mass of a gram, if I had 1,000 of these, I would have a kilogram, correct? If I slice this gram up into 1,000 pieces, 1/1000th, I would have a milligram, right? A liter chopped up into 1,000 pieces would be a milliliter. And a meter chopped up into 1,000 pieces, I would have a millimeter, correct? It works. Now, if you grew up with the metric system, this chart right here is exactly the same as what's on the green. Does everybody have a green? It's exactly the same. Is that roll sheet making it around, by the way? Roll sheet, where's that baby at? Roll sheet, single page, where's that roll sheet at? Got the roll sheet? Back to here. Try to get that going around. Let's get to make it around. One sheet's going to survive the whole semester. Try to keep that moving around. Okay. If you grew up with the metric system, you would have some chart like this memorized. If you have a base unit, write this in. This base unit, you're just looking at a single letter. That single letter for a base unit, it might be meters, might be liters, might be seconds, might be grams. But it's going to be a single letter. If we want to get larger or smaller units, we're just simply going to move the decimal because everything's based upon tens, hundreds, thousands, correct? For example, if you wanted to go to yards to inches in the English system, are you going to move the decimal? No. These are smaller units this way, larger this way. In the metric system, to go larger or smaller units, we're just going to move the decimal the same as what's in the diagram here. So for example, hold this over. Okay. I want, we'll do this one first. 1 gram to kilograms. This 1 gram is a base unit, right? Because it's a single letter. This is my base unit. It's a single letter. And this right here is kilo. Just using I'm just looking, my base unit is here, and I want to go to kilo. Which direction do my eyes go when I start at my base and I got to go to kilo? Left, correct? Left. 10 to the 0 to 10 to the third. You're looking at these exponents here. I need to move this. Starts out 10 to the 0 from my base. Kilo is 10 to the third. I'm going to move my decimal 3 to the left, huh? The same as the direction is in the diagram. And if I take this decimal right here, 3 to the left, I'm going to end up with 0.001 kilogram. Right? 0.001 kilograms. This is a base unit. Right? Single letter base. I'm going to start at mega here. 10 to the 6th. To go to my base, I need to go to the right, correct? 10 to the 6th, 10 to the 0. Move that decimal 6 to the right. Move the decimal 6 to the right. Does that sound correct? 6 to the right. The same as my diagram here. 10 to the 6th. 10 to the 0. We're going 6 to the right. So we're going to end up with, a million, correct? Centimeters to meters. This is my base unit again. So centi, I got to start at 10 to the minus 2. I got to go left to get to my base, right? I got to go left to get to my base, which is 10 to the 0. I'm going to go left 2. My decimal point's right here. So I'm going to end up with 0.01, huh? 0.01 meters. Millimeters to micro. So what do we got here? Milli to micro. Ooh, that's nice. That's not so bad. So this is millimeters, micrometers. We're going to go to the right. How many? 3 to the right. So 10 to the minus 3 to the minus 6 is going to get me 3 to the right. 1,000? And then nanoseconds here to seconds, nanoseconds to seconds. Nano here is 10 to the minus 9. I'm going to have to go left 9, aren't I? To get to 10 to the 0. So 10 to the minus 9, 10 to the 0. I got to go left 9 with that decimal. So I'm going to end up with 1, 2, 3, 4, 5, 6, 7, 8, and a 1. Right, that's going to get me 9 to the left. Okay, now, again, if you grew up in the metric system, you're just doing this for everything, right? This would be in your head. You're just going to move the decimal. Can't get any easier than that, right? Just move the decimal the same as what you would do on the chart. Well, things changed in America in the 80s when the automotive industry switched to everything metric. So Americans had to buy another set of wrenches, metric wrenches, okay? In America now, we cannot just move the decimal. Because we've got this shit show going on right here. Now, I type this up. This is how the metric system works. When I type this up, I copied this in Word, Control C, Control V to paste, Control V to paste. I came back and I changed the G's to M's for this one. In here, I changed the G's to L's because it works for everything, right? And then we've got this mess. Absolute disaster. Since we cannot move the decimal, we've got to do other things in the English system. Now, before you think I'm doing magic, watch this. Do not write this down. Do not write this down. Two feet one side, 3 feet the other side. How many square feet? 6, correct? In fact, you could actually do this. But you have 2 feet times 3 feet. Really looks like this. You've got 2 times 3 is 6. Feet times feet is 3 squared, right? I just multiplied units, correct? Well, if I multiplied units, I can divide units, right? So now if I say we have this, I messed that up. I messed that up a little bit. Let me redo that. I shouldn't have put those squares in here. All right, so let's say this is 2 feet. This whole thing is 8 square feet. What's X? 4 feet, yes? We could solve it like this. We can say 8 feet times 8 feet. And I'm going to divide this by 2 feet. 8 divided by 2 is 4. But look what happens here. You have to divide feet by feet. They're gone. Yes, that much. Then your answer is 4 feet, right? 4 feet. Now, as long as you have the same unit in the numerator as denominator, you're going to eliminate that unit, correct? Cancel that out. So, for example, I wish I I wish we would write this out. I might have to change this. I've got this problem right here. 1.2 decades to seconds. And this is how we have to convert in the English system. You start out with 1.2 decade right here. And then I make H's out of this. Most people know 1 decade, 10 years. Right? But The reason it looks like 1 decade, 10 years, and not 10 years, 1 decade is because I want the same unit numerator, denominator, so I can cancel out. Right? Now, if I wanted to know how many years were in 1.2 decades, I would stop. I'm going to add another true mathematical relationship. All I'm doing is adding another true mathematical relationship, which is this one. And that is 1 year is 365.25 days. Notice years and years cancel out. Yes? If I wanted to know how many days are in 1.2 decades, I would stop. You just keep going until the unit you want is left over. Every other unit should be eliminated or canceled out. So if I keep going, days would cancel out, right? And if I keep going again, hours cancel out, and I keep going again, minutes cancel out. I'm trying to get seconds. And I've got it, right? I usually do this next. Watch this now. In America, 2.375 yards equals blank inches. I'm going to start out with 2.375 yards. I need a true mathematical relationship. %90 of the students do this problem in 2 steps because I've done the data on this. 90% of the students do this in 2 steps, and 10% of the students do it in 1 step. Who's right? Doesn't matter. We can convert yards to miles to start this out, right? Doesn't matter how many steps you take. You just have to put true relationships here in what I call this conversion H. If we do this in 2 steps, what do you know about a yard? 3 feet, yes? 1 yard, 3 feet. That eliminates yards. I have feet there. I'm automatically putting feet down there. 1 foot, how many inches? 12 inches, right? If you do this in 1 step, that would do it in 1 step, correct? Doesn't matter how many steps. You just need to put true relationships. I call this a conversion H. I kind of like it that way. I don't know. True relationships in there, okay? $16 and $17. $135 ounces. We want to do a 16. Ounces to pounds? How many ounces in a pound? How many ounces in a pound? 16 ounces. 1 pound. That's going to eliminate ounces, yes. 1.75 miles to yards. One mile. What do you want to go to? 1 mile. What should we go to? You want to go to feet? You want to go to inches? Most people know this in feet. How many feet in a mile? 5,280. There's an easy number, huh? 1 mile. $5,280. I cross out miles, right? And now feet to yards. Three feet, 1 yard. And that would do it, right? That would do it. We'd eliminate feet there. Now, we're done at 5:15, correct? Am I right? It's 5:15. Okay. Now I'm warning you tomorrow or next time we meet, I'm going to tell you what a shit show the English system is. I'm probably going to kind of swear. I'm going to be passionate because it's a disaster what we're doing to our kids. And I'm going to present that. At this point, I'm going to give you quiz questions, correct? I'm going to pull out the take-home quiz. If you have questions on this, and I'm going to say this, you can poke around an owl, you can't hurt anything. And there's eight, I believe, in owl. You can go, you don't have to start at the top. I say poke around in the first homework in owl. Poke around in owl. Okay, here's the problems I want you to try so far on this quiz. Now, one more thing. One more thing. We're page 10 on this. Page 10. Looks like this. Page 10 on the review. I'll go. Not good. Be good with this. Were you able to write those in? All right, good. Okay, now, page 10 on the review. For next time, I want you to come through the door with this column filled in. All of the digits your calculator gives you. I want you to fill this column in. Do not do anything else. Fill this column in. This is a division. This is a division, multiplication, division, and multiplication. Fill this column in, all the digits, because next time we meet, we're going to talk about everybody's favorite significant digits. Sig figs. Okay. Fill this in. And we'll see you next time. Don't smoke, vape, get COVID, or stress your liver.
Do you want it?